Hello, ladies and gentlemen. Welcome once again to our virtual classroom. Today, we're going to be working on, or rather, we're going to continue working on equivalent ratios. This is not a lesson from our textbook. If you go to Schoology and if you go to Friday's folder, so we're in week 16, click on Friday, you will find where it says equivalent ratios. And you should get a screen that's like this. Just click Start New Attempt if you haven't started it yet, or Resume if you have, and that's where you'll find the problems for this assignment, as well as the problems that we're going to be using for our notes here in a second. All right, so like always, pause it, copy down the heading, especially for this first example. As you can see, this one's going to get a little wordy, so anytime that I ask you to copy something down, just pause it, copy it down, and then continue so that you can be doing it alongside with me. All right, so equivalent ratios. Remember, a ratio can be expressed as a fraction, and so in many ways, we're simply working with equivalent fractions, okay? And so our goal today is to use ratios um, to find out a missing value, equivalent ratios to find out a missing value. Let me show you what I mean by that. All right, so let's read number one. Again, pause it, write it down. I do want you to have this first one on your notes and then continue. Number one reads, the ratio of boys to girls is 3 to 2. If there are 12 boys, how many girls are there? Well, let's first identify the important information to see what we're working with. So we're working with a ratio of boys to girls. Remember that when we're working with ratios, the word to is extremely important. It denotes the two things that we are comparing. In this case, we're comparing boys to girls. Okay, that's important. And right here, they do something interesting because they say boys to girls is 3 to 2. And I do it in different colors to kind of help you understand that the order in which they mention things is very important. Boys is 3 because that's the first thing they mentioned. Girls is 2 because that is the second thing they mentioned. So boys to girls. Boys 3 to girls 2. Moving on, if there are 12 boys, so we have another quantity for boys. And here in the question, it's asking, well, how many girls are there? How do we do this? Let's set it up. Please write this down if you haven't done so. And because this is our first step is to write down the fraction in words. I'm going to call this a word fraction. We're going to write down the fraction of the two things that we are comparing. So again, what are the two things? What are those two things that we are comparing? Obviously, we're comparing boys to girls in that order. Typically, we just want to write them down in the same order that we saw them in the passage. So here we're going to write boys to girls, and I'm going to write it as a word fraction or a fraction in words. So boys over girls. If they had said girls to boys, then I would put girls first, but it's boys to girls. Ladies and gentlemen, this is the most important step. In the next few weeks, as we're working with ratios and percents and the like, and unit rates and rate of speed, writing the problem as a word fraction, writing the things that we're comparing as a word fraction is the most important step. That is going to provide the framework that is going to show us, give us a map of how we're going to solve this problem. If you do not get this part right, there's a very good chance you're going to get confused and or you're going to get it wrong or just not even know what to do. All right, so believe me, I know it seems so simple, but it is simple, but it is so important. All right, so we wrote it down as a fraction, boys to girls. Moving on, our second step is we're going to line up the ratio with the word fraction. Okay, so I have my ratio here already, boys to girls. So right next to that, I'm going to write the ratio that was given to me, and I'm going to make sure that it's lined up correctly. What do I mean by that? Well, we have boys in the numerator and girls in the denominator. Any number that I see in the problem that has to do with boys then is going to be in the numerator, and any number that I see in the problem that has to do with girls is going to be in the denominator. Remember, boys here was 3. So I'm going to put a 3 in the numerator. And girls here was 2. So I'm going to put a 2 in the denominator. And that's it. I have the word fraction, and I have the ratio lined up correctly. The boys with 3, the girls with 2. Awesome. So far, we just wrote down the problem. We wrote down the problem with words, so boys to girls. And then now we just lined up the ratio that was given to us in the passage, 3 to 2. We haven't really done any math yet. We're just organizing the problem. Number 3, now we're going to use the given information. We're going to use the given information to write an equivalent fraction. So we're going to write an equivalent fraction using the given information or the given variable. What do I mean by that? Well, if you go back to the passage, remember, they gave us a ratio, boys to girls is 3 to 2. But then they asked, if there are 12 boys, okay, 12 what? 12 boys? Remember, boys is in the numerator. Boys is in the numerator. That's where I put the 3 because that referred to the boys. If it says 12 boys, guess what? I'm going to put 12, not in the denominator, but in the numerator on the top as well. So I have boys. Everything having to do with boys is here in the numerator. So now that I've done that, I've set it up. I had boys in the numerator, 3 in the numerator, 12 in the numerator, and I have girls in the denominator. Girls in the denominator. 2 in the denominator with girls. And notice what the question is asking. Well, how many girls are there? We need to know what is the number that goes in the denominator that represents the girls when we have 12 boys. In other words, ladies and gentlemen, we need to write an equivalent fraction, a fraction that is equivalent to 3 halves that has a numerator of 12. What is the denominator? We're asking, what does the denominator have to be for these two fractions to be equivalent? At this point, ladies and gentlemen, all we have to do is ask ourselves, well, how do I get from here to here? Because whatever I did to get from this 3 to the 12 is the exact same thing that I'm going to have to do to the 2 to get to whatever I'm missing here. All right. Well, we're either going to multiply or divide. To get from 3 to 12, we have to multiply 3 by 4. We have to increase it by a factor of 4. And that is what I must do to the denominator as well. Multiply it by a factor of 4. All right. 2 times 4 is equal to 8. Ladies and gentlemen, that means that if I follow this ratio, following this ratio, if I have 12 boys, I need to have 8 girls. These two fractions are equivalent. If you don't believe me, go ahead and cross multiply. 2 times 12 is 24. 8 times 3 is also 24. Ladies and gentlemen, it checks out. These fractions are equivalent. I followed the ratio. Now that seems like a lot of information. It really isn't, though. Let me just recap everything that we did. All right, so the first thing that I did is that at the very beginning, I wrote down a fraction in words based on what I was comparing. So I was comparing boys to girls, so I wrote down boys in the numerator and girls in the denominator. That's my map. Everything that has to do with boys will be on the numerator. Everything that has to do with girls is going to be in the denominator. Next, I simply wrote down, now that I have my word fraction, I wrote down my ratio that was given to me, boys to girls here, right next to it. We're working sideways, right? Finally, I used the remaining information given to me in the passage, 12 boys, to make an equivalent fraction to 3 halves, except that now we have 12 in the numerator, and we wanted to find out what the denominator was. And I simply used a common factor, that factor being 4, 3 times 4 to give me 12. So I multiplied that same factor with 2 times 4 to give me 8. So on Schoology, ladies and gentlemen, the answer to this first one, answering the question, how many girls are there, is going to be 8. And that's it. Now, to show you how simple this is, that may have seemed like a lot because I use an entire page to show you that one problem. And I encourage you to go and rewatch that if you're a little confused. Let's do this next problem to show you how easy this really can be. All right, we read. Number 2, it takes one supergiant pizza to feed 3 people. If you invite 36 people, how many pizzas do you need? whenever we can write it on the text, we might as well do it. Okay, so let's write the important information. So we have one, that is one, right? One supergiant pizza. So one pizza to feed 3 people. Okay. If you invite 36 people, the question, we put it in brackets, how many pizzas do you need? Step number 1, even if we go back to our notes, we can see what that first step is. Step number 1, we want to write the fraction in words. What are the 2 things that we're comparing here? In this problem, ladies and gentlemen, we are obviously comparing pizza to people. So I'm gonna write it in that order just to keep it simple. So I'm gonna write pizzas in my numerator. And I'm going to write people in my denominator. And I'm going to keep the colors consistent to make it easier for you to see what I'm doing. Pizzas and people, those are the 2 things that I'm comparing. Step number 2, let me write the ratio that is given to me. What are the numbers? Well, I see that it's 1 pizza, 2, here's the letter, the word 2, right? The 2 is very important, to feed 3 people. 1 to 3, 1 pizza for 3 people. Great. Now let's use that to write an equivalent fraction using the other information given to me in the passage. Now it asks, well, if you invite 36 people, ladies and gentlemen, where is people, in the numerator or the denominator? It's in the denominator. So I'm going to put it in the denominator as well. Just like the number 3 for 3 people is in the denominator. So if we invite 36 people, and look, it's asking for how many pizzas, which makes sense because that's what I'm missing. How many pizzas do you need for those 36 people? Awesome. All right, let's see if there's a common factor that I can multiply them by. Obviously, I'm asking myself, what do I need to multiply 1 by? Well, I know that if I multiply 3 by 12, 3 times 12, that gives me 36. So I have to multiply 1 times 12. And 1 times 12, ladies and gentlemen, is equal to 12. So that's it. That means that if I get 12 pizzas, that'll be enough for those 36 people. Or rather, if I have 36 people, I better get 12 pizzas. That's it. The work that you see here, this is the kind of work that I want to see from you, beginning with the word fraction, lining up the ratio according to what you see in the word fraction, and then using a common factor to complete the equivalent ratio. That's it. That's the work that I need. Let us do one more, ladies and gentlemen. Number 3, at a recent party, it cost $9.50 for refreshments for 10 guests. How much would it cost to have refreshments for 80 guests? Okay, important information. So the cost is important. And the cost for refreshments, I'm just going to put cost, is $9.50 for 10 guests. You might as well say to feed 10 guests. Same thing. Question, I'm going to put it in brackets. And then it reads, how much would it cost? So we don't know the cost to have refreshments for 80 guests. Number 1, the word fraction. What are the 2 things that we're comparing here? And I see costs for guests. Costs, so cost is going to be my numerator. Cost, and I'm going to put that, put the $sign there so that it's pretty obvious what it is that we have there. Cost per guest. Cost for guests. Very good. Number 2, what is the ratio that is given to me? Well, I could see that it's $9.50 for 10 guests, so it's going to be $9.50 for 10 guests. So I'm going to put 10 guests. 10 goes on the bottom. Makes perfect sense. Now let's write an equivalent fraction, filling in the information given to me here. So I don't know the cost. I don't know the cost, but I know I do have 80 guests. So guests, again, that goes in the denominator because that's where I chose to put it. Awesome. Let's use a common factor. How much is it going to cost for 80? Well, 10 to 80 to get from 10 to 80. You're always either going to multiply or divide. Here, to get from 10 to 80, you have to multiply 10 by 8. That means that I have to multiply 950 by 8 as well. Let's work that out over here. So 950 times 8. 8 times 0 is 0. 8 times 5 is 40. 9 times 8 is 72, plus 4 is 76. And we have 2 decimal places. So ladies and gentlemen, in order to have refreshments for 80 people, you're going to have to pay $76. And that's it. $76. Awesome. We wrote down the word fraction, costs per guest. We lined up the ratio with the variable. So 950 was the cost, 10 was the guests. And I wrote down an equivalent fraction based on the information that was given. 80 guests went on the bottom, and I used common factors to figure out that I needed $76. That's it. As you can see, ladies and gentlemen, it's pretty simple now. And if you remember these steps, even as it gets more complicated, it is going to still remain pretty easy, even if it gets more complicated. That's it for now. We're actually not submitting this just yet. I recommend that you wait until Monday to do the rest with us, and I'll have another video going over the rest of these for Monday. But hopefully this was useful to you, as this is actually very important as we continue working with ratios. So like I said, that's it for now, ladies and gentlemen, and I will see you next time.